So the next part is the inlet, and this one is in millimeters. So again, when you create your part, make sure that you put it in millimeters. Name it, username, inlet. Make sure you save it to the U drive. Do not create this part with this broken out edge. They break it out and open the part up, if you will, so that you can see what's going on, okay? See features inside it. Remember that orthographic views are what we dimension, okay? The reason that an isometric view is dimensioned here is because they're giving this as an example problem for people to build and or dimension correctly. Okay, they have to give you the information without giving away the secret or how to dimension the orthographic view. So they give you the dimensions and they say, okay, you dimension it in the orthographic views. But we don't dimension isometric drawings in industry because, as you can tell, it's hard to read this stuff, okay? Yeah, someday all drawings will be done virtual in a 3D environment, you know, kind of like Minority Report or something. You'll be able to manipulate things and look at them. I've even seen people say that someday architects will be creating virtual buildings in 3D, like they'll have their virtual goggles on. You'll be able to walk through the building before it's ever built and see where all the piping and ductwork goes and everything, and before it's ever built, right? And for large, complex buildings, you know, that would help. For small things, it's not that important. So for now, we're given the information, and you do with it whatever you're told to do. So in this case, you're told to create a model, and in a couple of weeks, you'll be actually dimensioning some models. So we have a part that looks kind of like a megaphone, okay? The outside edge is curved, rounded and curved out like this, bell mouth. They call it a bell mouth. It's got some holes and a plate here. The part is probably named index or inlet because there's this rectangular hole in the side that's an inlet for probably some fluid or something. So it's a lot of dimensions, kind of hard to read, okay? I understand that. There are some geometric constraints you must notice. This radius of 112. Notice that the center point of that radius is along this line here, which is the front face of the part. Okay, that distance and that location is paramount to get this feature up here. Now there is a line here. There is a very short line here before this arc. Okay, you don't notice it until you've tried to draw it a few times, and it doesn't work unless there's actually basically this line here comes out until it meets that arc, and then you put a edge blend of 4 radius on it, and you can put that radius after you do this revolve. But you see these blue section lines here. This feature here, this face, if you will, that's opened up, that's the sketch you're going to create to revolve, and that'll give you like 90% of the part, just that fancy sketch. And then you create this rectangular double wall box and extrude it to cut into this part. But that has to be perpendicular. This sketch has to be perpendicular to the inside edge here. Notice it says 90 degrees. So this sketch of this rectangle has to be on that line, that inside line, and that will form a plane parallel to the inside curved surface. So the inside surface, this is a straight line that will create a curved surface, and the outside line is curved that will create it like a double curved surface. It's a rounded surface that's curved. The rectangle here is, the wall is 3 millimeters wide. The radius of the outside is 5 millimeters, and it's also curved on the inside, and if it's 3 millimeters wide, that means the inside is 2 millimeters. They always give you enough information that you can find any dimension they don't give you, but you have to use your head a little bit, okay? Most of these dimensions I have memorized, so I'll go fairly quickly through this, hopefully. Okay, we're going to do a revolve. we're going to create it on the sketch on the horizontal plane, just like the book shows. So we are now on the horizontal plane. I'm going to draw from this horizontal line upwards, so I'm going to be drawing in the first quadrant, and that will be this shape here. Just as reference, this whole part is 88 millimeters long. So I'm going to go from this line and draw 88 millimeters and click to drop it. And that's our reference of how tall this part is. I'm going to zoom in on it. Now I can draw a profile of approximately what this thing's going to look like. And I'm going to start here. And the thickness of that outside wall is 4 millimeters. It is a 52 diameter circle and a 44 diameter circle, which the difference is 8 millimeters. So the wall thickness is half of that, or 4. So there's my 4. And then it's going to be 16 millimeters tall. Oh, I got that right. And now the question is, are we going to draw it all the way to this? This is going to be the center of the megaphone, or the inlet. Okay, it's going to be the center. So that total distance, since the hole is 44 millimeters diameter, this would be 22. But I'm going to draw it right to the center, and when I change that, I'll be right on that center. And this comes right back to there. And then we go up like this. We don't know what the length of this line. Up like that, over like this, down like that, over like that, and then we're going to put an arc from here to there and bend it in. Okay. This dimension is supposed to be 6. Zooming in this dimension, and a lot of times to create a fancy sketch like this, a lot of lines, it's best if you take a pencil and a piece of scrap paper and actually draw this sketch out on that's how I did it the first time. Draw it on a piece of paper, draw your vectors where you're going to revolve it about, draw it on a piece of scrap paper, and take your dimensions from your drawing one at a time and put it on your sketch. Okay? Look carefully on that busy drawing and find the dimension you want and put it on the sketch until the sketch is done. That will save you so much time rather than just keep staring at the thing trying to get it to work. Okay, so this line here that's 22. That's 6. This is 16. As far as I can tell, the both sides, oops, sorry, that's 22 also. Both sides are the same length. Now we don't know how long this line is, but we do know that the inside diameter of the large end is 40. 40 diameter, 80 diameter, which is 40 millimeters radius. And it looks like I have to make this thing vertical. Come on, vertical you are. Okay. And it is, if you do the math, it is 22 millimeters deep, because it goes from 88 down to 80. 88 down to 66, yes. So that's 22. Let's see if we can move this back to where it belongs. Yeah, I wish I knew how to change those dimensions so they're smaller. One more dimension. This dimension. In version 11, these dimensions would automatically shrink as you zoomed in. There's some setting that you can set so it's auto adjusting, but I don't know where it's in this version, so when I figure it out, I'll let you know. Could not be edited as requested. Try relaxing dimensions and or relationships. So I'm not sure what it's. Oh, you know what? This endpoint is stuck on the midpoint of that line. I can almost guarantee it. So let me redraw it. Let me do a corner, make corner. Okay. Let me do a make corner from here to here. Maybe it won't make a corner from there to there, huh? Let's put this dimension in here. Let's get rid of that line. We don't need it. And let's put a radius of 112. I gotta wait until it pops up. I'm too quick for it. And let's see if I can move this to there. Okay, so there's my radius. And I want to put a dimension from the center of this arc, which is here, to this line. And that dimension these things didn't go horizontal, so let's make that horizontal. Yeah, these dimensions being this big is just a real pain. Okay. This line here is supposed to be 8. Boom. Something's wrong. Oh, the overall height. The overall height from here to here is 88. That looks correct. I still got. Is it done? Sketch is partially defined. Okay, let's see what we're missing. Oh, this line has not been defined. Or dropped a dimension. So that one is 16 millimeters. 1/6. Notice that the colors, before I put that last one in there, this line was a different color than the rest. They're supposed to turn black when they're done. Okay? Watch me back it up. See that? They're like this brownish. That means these are the lines that are not constrained yet. So you click on one of these endpoints and try and move it, and you'll see what's missing. Let's go forward again. There we go. And forward again till that's 16. It is now fully defined. I hit finish, revolve. That about Oh, let me tell you one more thing. Something that a mistake I often would make, and that I would be thinking in my head, I'm going to revolve a sketch, but instead of revolving it, I would accidentally click on extrude when I was creating the sketch, because you just get used to doing things. And I would do this whole fancy sketch, and then I would pop out of it, hit finish, and it would try to extrude. I went, oh no, I wanted to revolve that, not extrude it. There's a fix for that, okay? What you do is you hit the cancel button, and before it deletes the sketch, it'll say, do you want to keep the sketch? You're deleting the extrude. Do you want to keep the sketch? And you say yes, and you will keep the sketch. And then you'll do what I did right here. It's like, now you have the sketch. All you have to do is go into the sketch and choose a new revolve. So we're going to choose this vector, or we could have chose that line. We're going to go from 0 degrees, tab, 360. Okay, there it is. We got to put in this 4mm curve here in this end. You know what? I'm going to go only 270 so you can see what this looks like inside. There we go. And say OK. By the way, by clicking on your mouse and stuff, at times you may make something invisible. Let's see if you can still do that. If you right click, let's see, face with edges, that's typical. If you go over here and let up, you'll have faces without edges. They used to have, oh yeah, right here. If you accidentally hit the mouse button 3, you could make your part wireframe. If it's like this on you, you right click on the mouse and go up and let up. Okay, so we have this part here. What we want to do to put this inlet, this rectangular part on here, is to put a datum plane on this inside plane here, this inside blue line. So we're going to go to datum plane, and remember I told you there's lots of ways to make a datum plane. Plane orientation right up here. Lots of different ways. We want to do a plane by making it tangent with another plane, so just choose the inferred here, probably already by default chosen, and we want to choose this line here. Now we are picking the sketch line that exists. Okay, that's not quite the plane we want, but it's close. Okay, what we want is more information. We don't want the plane perpendicular to a vector that runs down it. We want to pick this plane, or this surface. When we click on that, notice what it does. It says, oh, you mean you want it perpendicular to that surface, right? That's what we want. And then we say OK. That's the plane we're going to sketch on. Now sometimes people will have this thing, for one reason or another, they'll have their sketch turned off, okay, hidden inside maybe the revolve command. And they go into, they open it up like this, and then they say, okay, I want to put a datum plane. And they go to datum plane, and they say, well, I want to put the datum plane here on this point. Okay, this point only exists when you have this part opened up. Okay, you have this plane only because the part is revolved, not 360 degrees around. Okay, so here's the problem. If you create a datum plane on the edge of a solid, that disappears when you close the thing and revolve it 360 degrees. Where's the datum plane defined? Because the datum plane was defined on the edge of a solid, not on the edge of a sketch. Okay, that's why I left the sketch on, because I'm picking the sketch line and then the surface. So anyway, okay, there, yeah, we don't want this datum plane. So I'm just going to back that up. Okay, I'm going to go to extrude, hover on the surface of that datum plane till it highlights, and then click on it. Now you are on that datum plane. You then create a rectangle, click, let up, drag, click to drop, click. This thing is 34 by 19. And it's symmetrical, so go from this line to the top line and make it half of 34. So 34 divided by 2. Well, one thing here, notice when it gives you this this dimension here, okay? It says parameter P9 equals 17. P9 equals 17. P stands for parameter, ninth parameter that you've created. This is so that you can program something. So you could go in another part or another line in this part, and you could make one line in relation to another line. Okay, so if I went to another, I could always call this line and say, I'll make it twice as long as P9. Okay, that's what that parameter is there for. So you can define things by other lines, other arcs, whatever. And it could even be a line in another part. So you could say, well, here's my part, and it's got a lid, and I got this part, and I got a part that's twice as big. And if I define my lid part with the parameters in the box part that I start with, then I could change the size of my box, make it twice as big, and my lid would become twice as big too. Okay, so it's programmable. Now the last thing we have to do is move this thing, right? It can still move. It can't move up and down, but it can move left and right. And we want to move it so it's on this point. If you look carefully on here, the inside edge of this box looks like it's right there on that point. So that's what I'm going to do here. Yeah, ask me how long it took me to realize that. Quite a while. Zero. Okay. Now I'm only creating the outside of this box. I'm going to go from 0 outward. It is 8 millimeters deep. I'm not creating the inside hole too, because if I created them both, think about this, the inside hole wouldn't go all the way through the part, okay, because it only touches the inside edge at this line here. So I'm going to create that. I'm going to unite it, say OK. Now is probably a good time where I can close this. Right click, edit parameter, make it 360 degrees. Hit none. I hit OK. Okay, the only thing I can do is delete this. Try it again. Extrude that plane. There we go. Rectangle. 2-point rectangle. $34. 19. Okay. So I'm going to fudge it. I'm going to put it right to there. I don't know how to turn on that snap in the background. Okay, so we go 8 units out, we unite it. Okay, we then go extrude on this face. We do a rectangle. So let's see, 34 minus 6, so 2 wall thicknesses. And this one is 19 minus 2 wall thicknesses. And how do I measure from there to there? How do I measure something in the background? Function F8. NX11 always lets you snap to things in the background. So I could put a dimension from here to there, if that's the right distance. 3. Okay, that looks right, but finish. And this one's going to go the other way. Be careful, don't drag it too far, you'll hit the other wall. And subtract. And then we can do some edge blends. We got this edge, which is 4 millimeters, and apply that. We have 5 millimeters for this, 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 and this, and apply that. And we have 2 millimeters for the inside. So that's 2. Okay, and there. Now all we gotta do is put the holes here. So this is, center one is 12. And the best way to do these in the center and the inside here is to do probably one and do a pattern. Create a cylinder, 28 diameter. And go to menu, tools, convert to reference, and convert that to a reference. Then you can do a circle, 6 millimeters diameter. Finish that one, extrude it, subtract it, pattern. Where's my pattern? Pattern of my last feature. Circular 4, count of 4, 90 degrees apart. Tab. Specify the vector. Is that Y vector? Okay. Finish. I'm going to leave that datum plane on there. Save it. And that's the inlet.